What if I told you that our galaxy is eating other galaxies right now? Or that there is a giant black hole at the center of the Milky Way, whirling stars around it at over 7,000 kilometers per second? Or that most of our galaxy is made of something we cannot even see? On a truly dark, cloudless night, far from city lights, if you look up at just the right time of year, you might witness a soft, glowing band stretching across the sky. That faint streak of light is not just a beautiful part of the night sky. It is actually our home, the Milky Way Galaxy. Yes, the very galaxy our solar system belongs to. And the amazing part? You do not need a telescope to see it. The Milky Way is one of the few galaxies visible to the naked eye. Our ancestors saw this same sight thousands of years ago, and because of its milky appearance, they gave it the name we still use today, the Milky Way. In this video, we will uncover 15 fascinating facts about our galaxy, including invisible matter, cosmic collisions, and ancient stars older than we ever imagined. Some of these facts may surprise you. Some might even change how you see our place in the universe. Hi friends, welcome to another episode of Science Simplified for All. We have been seeing the Milky Way in the night sky for generations. For a long time, people believed that what we were seeing was the entire universe. It was Edwin Hubble who first realized that some of the faint smeared dots seen through telescopes were not just stars, but entire galaxies in their own right. That is when we began to understand that the white band of light we call the Milky Way is not the whole cosmos. It is our own galaxy, seen from within. We now know that the Milky Way is a spiral galaxy, just like many others we observe in the universe. But here is the interesting part. No one has ever actually seen it in its spiral form. Because we are viewing it from the inside, what we see is only a side view, a thin, glowing slice of the galaxy's disk. That is why it appears as a streak of light across the sky. Still, thanks to precise measurements of the positions and motions of countless stars, astronomers have been able to reconstruct the Milky Way's true shape with remarkable accuracy. This video is arranged as a countdown of fascinating facts about our galaxy. So let us begin with fact number 15. Our Milky Way galaxy is estimated to be around 13.5 billion years old. That is incredibly close to the age of the universe itself, 13.8 billion years, which means the first form of our galaxy began to take shape just 300 million years after the Big Bang. But how do we know that? One way is by looking at the age of the oldest stars in our galaxy. Among them is a star nicknamed Methuselah, named after the oldest person in the Bible. When it was first studied, Methuselah's age was calculated to be 14.5 billion years, which oddly seemed older than the universe itself. However, more accurate measurements later revised its age to about 13.6 billion years. The existence of such ancient stars gives us important clues. It tells us that the Milky Way had already begun forming in the earliest phase of the universe, just after the first stars were born. The Milky Way did not always look the way it does today. It is true that the earliest structure of our galaxy had already begun to form within 280 million years after the Big Bang. But that early version was small, irregular, and far less organized than the majestic spiral galaxy we see today. Over billions of years, the Milky Way grew by merging with other galaxies, devouring them through gravitational interactions. Recent studies show that our galaxy has collided with and absorbed at least 2 or 3 medium-sized galaxies in its past. Each collision added more stars, more gas, and more structure, slowly shaping the Milky Way into the grand spiral system we now call home. The Milky Way is not alone in space. It is surrounded by a group of smaller companion galaxies known as satellite galaxies. Astronomers have identified at least 40 of them, orbiting the Milky Way under its gravitational influence. The most prominent among these are the Large Magellanic Cloud and the Small Magellanic Cloud. These are visible to the naked eye from the southern hemisphere and were first described to Europeans by the explorer Magellan, hence the name. Despite being called clouds, these are not just gas clouds or nebulae. They are actual galaxies, each containing billions of stars. Another interesting satellite is the Leo 1 dwarf galaxy. Though much smaller and fainter than the Magellanic clouds, Leo 1 drew attention recently when astronomers found strong evidence of a massive black hole at its center, possibly as massive as the one at the heart of the Milky Way. This was unexpected because such large black holes are usually found only in much larger galaxies. Until now, it was believed that supermassive black holes formed mainly through the merger of massive galaxies. The discovery in Leo 1 challenges that idea and suggests that black holes in small galaxies may be more common than previously thought. Scientists are now studying this further. The Milky Way has not just merged with other galaxies in the distant past. It is still doing it today. Even now, our galaxy continues to pull in and absorb smaller satellite galaxies that stray too close. Two such galaxies, the Sagittarius dwarf elliptical galaxy and the Canis major dwarf galaxy, are currently being gradually torn apart by the Milky Way's gravity. As this happens, entire star clusters get pulled apart into long, thin streams, leaving behind glowing trails that trace the path of their destruction. These are called stellar streams, and they are visible evidence of galactic cannibalism in action. Earlier, we mentioned the Leo 1 dwarf galaxy, which has a massive black hole at its center. Some scientists believe Leo 1 may eventually be pulled in and merged with the Milky Way too. If that happens, its black hole could one day merge with Sagittarius A star, the supermassive black hole at the center of our galaxy. However, for now, Leo 1 remains intact and shows no clear signs of being absorbed yet. For a long time, scientists believed that the Milky Way's disk was about 100,000 light-years across, because that is the diameter of the main visible part of the galaxy. This was the standard figure found in textbooks and science articles for many years. But newer observations have expanded that estimate. They suggest that the outermost stars and gas clouds in the Milky Way's disk may extend up to 100,000 light-years from the center in some directions. That means the galaxy's total diameter could reach as much as 200,000 light-years when including its faint outer regions. And it does not end there. There are even isolated stars far beyond the visible disk that are still gravitationally bound to the galaxy. As for its thickness, the Milky Way's main disk is about 1,000 light-years tall at its thickest part and around 300 light-years thick in other regions. Compared to its overall diameter, the galaxy is relatively flat, like a cosmic pancake made of stars, gas, and dark matter. The Milky Way Galaxy is estimated to contain anywhere between 100 billion to 400 billion stars. That wide range exists because we are observing the galaxy from the inside, and that makes it incredibly difficult to get an exact count. Thick clouds of dust and gas in the spiral arms block our view, especially toward the galactic center. So many stars remain hidden from our sight. With visible light, we can typically see only about 4,000 to 6,000 light-years deep into the Milky Way. Beyond that, the view becomes hazy and incomplete. To look farther, astronomers use radio waves, which can pass through dust clouds much more easily than visible light. Using large radio telescopes, we can peer deep into the galaxy and map out stars and structures that would otherwise remain invisible. Even so, the total number of stars remains an estimate, because the Milky Way is far too vast and complex to count star by star. The Milky Way is massive, far beyond what we can intuitively imagine, but astronomers have a reliable method to estimate its total mass. The trick lies in observing how fast stars orbit the galaxy. According to physics, the orbital speed of an object depends on how much mass is inside its orbit. By measuring the speeds of the outermost stars, we can estimate the total gravitational pull and from that, the total mass of our galaxy. So how much does the Milky Way weigh? It is estimated to have a total mass of around 1.29 trillion solar masses. That means it has the combined mass of roughly 1.3 trillion suns. But here is the surprising part. Most of that mass is invisible. About 1.1 trillion solar masses, or nearly 85%, is made of dark matter, a mysterious substance we cannot see, but we know is there because of its gravitational effects. Only about 200 billion solar masses is made of normal, visible matter, the stuff we can observe through telescopes. Out of that visible matter, roughly 15% exists as scattered gas and dust, while the remaining 85% forms stars. And even though the Milky Way contains between 100 and 400 billion stars, their combined mass adds up to only about 160 billion solar masses, because most stars are smaller and lighter than our Sun. At the very center of our galaxy lies a powerful and mysterious object, a supermassive black hole known as Sagittarius A star. When we look up at the Milky Way in the night sky, Sagittarius A star is located in its brightest and widest region. But we cannot see it directly. It is hidden behind thick clouds of dust and countless stars. However, it reveals itself in another way, by emitting strong radio waves. That is how astronomers first detected it, as a compact radio source buried deep in the galactic core. The existence of Sagittarius A star as a supermassive black hole was confirmed through years of careful observation. Astronomers Andrea Ghez and Reinhard Genzel tracked the motion of stars orbiting this invisible object. Some of these stars were moving at over 7,650 kilometers per second. That is about 2.5% the speed of light. Their findings proved that the only object compact and massive enough to cause such motion is a black hole. This discovery earned both scientists the Nobel Prize in Physics in 2020. Sagittarius A star has a mass about 4.3 million times that of our Sun, yet it fits into a space only 43 times the Sun's diameter. In spite of this enormous mass, it makes up just 0.00031% of the total mass of the Milky Way. This is very different from the scenario in our solar system, where the Sun holds more than 99% of the total mass and entirely controls the motion of every planet. In the Milky Way, Sagittarius A star, though massive, plays only a minor role in the motion of stars spread across the galaxy's enormous disk. Instead, that motion is governed by the combined mass of everything in the galaxy: stars, gas, dust, and especially dark matter. Right now, Sagittarius A star is considered an inactive black hole, meaning it is not consuming large amounts of matter. There is no bright accretion disk around it, and it only emits occasional bursts of energy when gas or dust comes too close. Yet, using powerful radio telescopes across the world, astronomers were able to capture its shadow in 2022, giving us the first ever image of Sagittarius A star through the Event Horizon telescope. The Milky Way is not just a spiral galaxy. It belongs to a specific type called a barred spiral galaxy. In this structure, a long central bar made of stars runs through the galactic core. It is not just a bright spot at the center, but a stretched, elongated feature where many stars are densely packed. If we could observe the Milky Way from far above, looking down on its disk, this central bar would be the most prominent and brightest feature we would see. From both ends of the bar, several spiral arms extend outward, curving gracefully as they rotate. These arms contain vast numbers of stars, gas clouds, and star-forming regions, giving the Milky Way its familiar spiral shape. Together, the central bar and the spiral arms form a flat, rotating disk. Surrounding this disk, above and below, is a halo region. It contains very old stars, scattered gas and dust, and it forms a faint, spherical structure around the galaxy. Also within this halo are globular clusters, compact, spherical groups of ancient stars. Interestingly, many of these globular clusters orbit the galaxy in the opposite direction to the rotation of the disk, offering clues about the Milky Way's early merger history. As mentioned earlier, about 85% of the Milky Way's total mass is made up of something we cannot see, dark matter. Unlike the stars, gas, and dust that form the visible part of the galaxy, dark matter does not clump together or form structures like spiral arms or star clusters. Instead, it surrounds the entire galaxy in a vast spherical halo. This invisible halo stretches far beyond the edge of the Milky Way's visible disk and plays a critical role in holding the galaxy together. Based on the mass of visible matter alone, the stars in the outer regions of the galaxy are moving far too fast to be held by gravity. They should have flown off into space long ago. But thanks to the extra gravitational pull from dark matter, those stars remain bound, moving around the galaxy's center in stable orbits. We cannot see dark matter directly. It does not emit, absorb, or reflect any form of light. The only reason we know it exists is through its gravitational influence on the stars, on the motion of galaxies, and on the shape of the universe itself. Dark matter is one of the biggest unsolved mysteries in modern science, and yet, without it, galaxies like ours simply could not exist. In 2010, astronomers made a surprising discovery. Using the Fermi Gamma-ray Space Telescope, they detected two enormous structures extending above and below the center of the Milky Way. These formations are now known as the Fermi bubbles. Each bubble stretches about 25,000 light-years from the galactic core, making the full height of this structure nearly 50,000 light-years. These bubbles emit powerful gamma rays and X-rays, and are believed to be filled with high-energy particles, especially fast-moving electrons. But how were they formed? One leading theory connects them to Sagittarius A star, the supermassive black hole at the heart of our galaxy. From time to time, Sagittarius A star may pull in clouds of dust and gas. This could trigger energetic jets of particles that shoot out above and below the galaxy, creating structures like the Fermi bubbles. Even today, scientists are still trying to understand the exact cause of these bubbles. But one thing is clear: they are a visible imprint of the Milky Way's violent past. Our galaxy is not isolated in space. It belongs to a small collection of galaxies known as the local group. The local group includes the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy, along with dozens of smaller satellite galaxies that orbit them. The Milky Way and Andromeda are the two largest members, each with their own family of smaller galaxies. Triangulum is the third largest. Together, they form a gravitationally bound group spanning about 10 million light-years across. But it does not stop there. The local group itself is just one part of a much larger structure called the Virgo supercluster, a vast region of space containing thousands of galaxies. In short, the Milky Way is just one spiral galaxy among billions, drifting through space as part of a vast cosmic web. The Sun, along with the entire solar system, is not fixed in one place. It orbits around the center of the Milky Way. Our Sun is located about 28,000 light-years from the galactic center. At this distance, it travels at an average speed of about 230 kilometers per second. At that speed, it takes approximately 230 million years to complete one full orbit around the galaxy. This long journey is known as a galactic year. Since the solar system formed around 4.6 billion years ago, the Sun has completed only about 20 orbits around the Milky Way. So, in cosmic terms, our Sun is still a relatively new traveler on this galactic path. The planets in our solar system orbit the Sun in a flat disk-like plane known as the ecliptic plane. But this plane is not aligned with the main plane of the Milky Way Galaxy. The Milky Way itself is shaped like a giant rotating disk. However, our solar system is tilted at an angle of about 60 degrees relative to the galactic plane. In the image shown, the galactic plane is like this, while the plane of the solar system is like this. This misalignment becomes obvious when we look at the Milky Way in the night sky. The glowing band of stars stretches across the sky at an angle, not straight or horizontal, because our solar system is tilted compared to the galaxy's plane. Interestingly, the solar system's path around the Milky Way is not perfectly flat either. As it orbits the galactic center, it gently weaves above and below the galactic plane in a slow, wave-like motion, like riding a ripple through space. Still, the solar system stays well within the thickness of the Milky Way's disk, which spans about 300 light-years vertically at the point where our solar system lies. The Andromeda Galaxy is the closest large galaxy to the Milky Way, and it is significantly larger than our own. But more importantly, it is moving towards us at a speed of about 110 kilometers per second. In roughly 4 billion years, the Milky Way and Andromeda are expected to collide in a slow, gravitationally driven cosmic merger. This event will not be an explosive crash. Stars are so far apart that direct collisions between them are extremely rare. But the structure of both galaxies will be torn apart and reshaped by gravity. Eventually, they will merge into a single, much larger elliptical galaxy, nicknamed by some scientists as Milkomeda. During this process, the supermassive black holes at the centers of both galaxies will also merge, forming an even more massive black hole at the center of the new galaxy. While the exact outcome is difficult to model in detail, one thing is certain: our galaxy is on a slow but inevitable path to transformation. We often think of the Milky Way as just a quiet backdrop in the night sky, but behind that soft glow lies a galaxy that is ancient, massive, and constantly evolving. From hidden black holes and invisible halos of dark matter to entire galaxies being pulled apart and absorbed, our Milky Way is far from still. It is a dynamic, living system that holds the story of cosmic creation, destruction, and rebirth. And the most amazing part? We are right inside it, orbiting quietly on one tiny planet, trying to understand the galaxy we call home. If this journey through the Milky Way gave you a deeper sense of wonder, do consider sharing the video with someone who might enjoy it too. And if you would like to explore more such scientific journeys, do subscribe and stay tuned to Science Simplified for All. Thanks for watching.